Hi, everyone. Finally, we're going from the PRIs, the power-reducing identities, to these 5 half-angle identities. So we're going to get numbers 15 through 19. And this time, unlike double angle, where we had 3 for cosine, this time we're actually going to get 3 for tangent. There are 3 half-angle identities for tangent. And if you have a rigorous calculus teacher down the line, you might run into these various versions. Okay, well, here they are. And if anything, it might be easier if you just derive these from the PRIs using your algebra. But here they are. For example, sine of half theta, or theta over 2, is plus or minus. First of all, before I forget, you need to state that you have to choose the appropriate sign based on the quadrant that theta over 2 is in. You have to pick the sign appropriately. So choose the sign appropriately. You technically have to make that note. So it helps to know what quadrant theta over 2 is, or maybe it's quadrantal. All right, so here the plus or minus, it's not like in the quadratic formula where you just grab both. You actually have to choose which one to pick. Of course, when stating the general identity, we don't know yet, so leave it as a plus or minus here. The square root of, this is the first time we're seeing square root, really. 1 minus, because remember, sin is bad, sin is negative, you have a minus sign there. Cosine of theta, all over 2. And if this kind of smells like the PRI, it should. We're going to get this from the PRI. And again, what's the half angle identity for cosine? There's only one difference. The minus here goes to a plus here. And if you're actually doing an evaluation, you may get different signs over here. But for right now, generically, let's leave the plus or minus in there. But again, the plus sign here is different. Sin is bad, sin is negative. Cosine, we have the plus sign. And for tangent of half theta, well, we have plus or minus the square root of. Well, again, we're taking the quotient. By the quotient identities, it's going to be this guy over this guy. Again, we have a plus or minus deal. The square root of, and the 2's basically knock each other out. So it's the top of the sine version, 1 minus cosine of theta, over the top of the cosine version, 1 plus cosine of theta. Again, it looks like the PRI for tangent. So that's how we get numbers. So this would be number 15, and then number 16, and then number 17. And then later on, I'll show you how to get number 18, which is where tangent of half theta equals this guy, and number 19, our last guy, where tangent of half theta also equals this guy, and there's no ambiguity in signs. We'll talk about that. Okay, now, as I mentioned before, it might be easier to derive this directly from the PRI instead of memorizing this. How do we do that? Okay, so let's go down to the proof over here. All right, so here's a PRI. It's number 12, I guess. It's number 12. Right. Sine squared of u equals 1, which sign? Sin is bad, sin is negative. That's a minus sign there. Cosine of 2u all over 2. But we now want to replace u with theta over 2, or half of theta. So I'll perform this substitution. U is half theta, so therefore, if you solve for theta, theta is twice u. We have both these relationships. They're consistent. Okay, now, so we have sine squared of now half theta, or theta over 2. This equals 1 minus cosine of theta, because you're doubling this argument. Half theta goes to theta, all over 2. So we have, when you apply the square root method, okay, remember, for the square root method, if x squared is 7, then x can be what? It can be plus or minus the square root of 7. hence plus or minus the square root of this over here. Again, it might be easier to perform this derivation, know the PRI, and perform this derivation where you have this substitution. Again, the choice between the signs will depend on what quadrant theta over 2 lies in, or maybe it's quadrantal. It's a similar deal for cosine, right? I mean, cosine squared of u had a plus sign, so therefore you had a plus sign for the cosine version. And for tangent, you take the quotient. Okay, so 15, 16, and 17 should make sense. But now, how do you get from 17 to 18 and 19? Well, I'll talk about the verification of that in a later video, maybe a later day, in fact. But right off the bat, let me ask you, if you're a tutor, how would you tell a student to go from here to either here or here? So just manipulating this expression, just mechanically, if you're a tutor, what would you tell a student to do to this ugly expression over here to get to these nicer expressions, number 18 and number 19? Ignore the trig details for now. We'll deal with that in a later video. Just purely brute force mechanically. Just in terms of writing things. What do you do to this expression to get either of these two guys? What are the 4 changes you make? And I'll give you a hint. Start by asking the following question. What is here that's missing in 18 and 19? What disappears as we go from number 17, the right-hand side, to these right-hand sides for number 18 and number 19? Technically, these identities also have this as the left-hand side. These are the right-hand sides for these new identities. How do we get from here to here or here? First of all, what do we remove? We remove that plus minus symbol, right? So the sign of tangent of half theta will come out automatically from these formulas, assuming it's a real value. Bear in mind, this could be undefined. Second, there's something else we remove. We remove that ugly square root radical. So we also remove that ugly square root radical. Those are 2 things we remove. Now, what about the top and the bottom, the numerator and the denominator? Well, we replace either the numerator or the denominator with sine of theta. We replace either the top for 19 or the bottom for 18 with sine of theta. And then the other stays the same. Actually, come to think of it, it might be easier if I phrase it the other way, huh? So maybe I should say this. Maybe I should make this number 3. Keep either the numerator or denominator. For number 18, we keep the top, the numerator. For number 19, we keep the bottom, the denominator. And then number 4, then you replace the other piece. Replace the other. Okay, so if you keep the top, you replace the bottom with sine of theta. If you keep the bottom, then you replace the top with sine of theta. There you go. So that might be an easier way of phrasing that. All right. Maybe I'll move these all up. So you remove plus or minus. There's no more sign ambiguity. Remove the radical. Okay. Keep one part, the top or the bottom, and change the other part to sine of theta. Okay, in the next video, I'm going to help explain how we get these. How do we get these? And that's going to be very related to some homework problems I had you do, like on verification back in 5.2. That's next time. But in the meantime, hey, we have the 19. And by the way, for these 8, it's a matter of when you see them, be able to use them. Okay, we'll get to that later.